Okay, let's talk a little polyatomic ions here. Polyatomic ions are basically kind of like the same thing that we've been working on with cations and anions, only they're a group. They just act like one. So the whole group of elements together still just has one charge with all of them. We don't change that group. We hardly even change its name. So we never change its ending as well. So we've been dealing with binary compounds so far. That's compounds that have two parts. We're still dealing with compounds that have two parts. Only this time, when we're talking about the anion or the negative, you're not just going to see one element there. You're going to see a group of capital letters. Okay, so that's your tip-off when you're looking at a compound. If you see more than two capital letters, then you know that you're dealing with a polyatomic ion. Poly means many. So we have many elements that make up this one ion. So, like it says in our notes, it's a cluster of atoms that act like a single ion. So we will just use that single charge, just like we've been doing for all ionic compounds. All right, so this says, for example, if you're asked to write the formula for sodium sulfate, we recognize from the ending ATE that it's a group. When we look at the name, and usually names have been ending in IDE, and now we see something like ATE or ITE, then we know that that's tipping us off to looking at the polyatomic chart as well. Okay, so we can either count those capital letters and see that there's multiple in the formula, or we look at the name and we notice that the ending of the name is something other than IDE. Okay, here we go. So if we look at this box, this came off of page 8 in your notes. And we were just having practice looking at the polyatomic group that's included right on your periodic table. All right, so we should start to recognize some of these groups. One common property that I see quite a bit is that when something ends in ATE, there's often 3 oxygens in there. Not always, but quite often we start to see that pattern. Here's carbonate, for example, which is CO3. Here's nitrate, which is NO3. Now the sulfate and the phosphate end up having PO4, but we're seeing these groups now. And the whole group of them together still just have one charge. So this carbonate polyatomic ion is an anion, meaning it's negative. And the whole group just acts as one. And we balance it just as if it was something like chlorine, which has a -1, or oxygen, which has a -2. This time it's carbonate, which has a -2. So if we have to add more carbonates, we will just put brackets around them and double them up, triple them up, and put their little number of how many we used down on the right side as a subscript, like we've been doing for the others. Okay, so we don't change anything, but you can see there's multiple capital letters in all of these. And I don't know if you've noticed, but there's really only one positive ion here. Ammonium is the only cation on our list. The rest are all anions, so they would be on that back half of the compound that we're balancing with. So positive balanced with the negative. Okay, so this first exercise just has you kind of hunting and finding some of your polyatomic ions. So we're looking for silicate. We're looking for sulfite. Here we're noticing that we've got a single ion because it has this charge, but there's 1, 2 capital letters just in the negative ion. That shows it's a group. Here we've got N and O, shows it's a group. Here we've got 1, 2, 3 capital letters or 3 elements in this ion, so we know it's a group, and so on. OH is one that you should start to recognize. This is hydroxide. It indicates that it's a base once we get looking at acids and bases. All right, so this exercise was great. It just had you going back to your table. If we look for silicate, it has you going back to your polyatomic group and hunting and finding the different groups here. So silicate, I should have picked this one where I knew where it was right off the bat. Here we go. There's silicate. SiO3 with a 2 minus. All right, so just a big group we balance just like it's one negative ion. All right, so we'll do 1 or 2 here for our video. Here we've got, I'm noticing that I have 1 capital letter, 2, 3, so it's telling me that I've got more than 2, it's polyatomic. So the positive cation is sodium, and sodium has a charge of +1. It's an alkali metal. It's in the first column of our periodic table. And because there's a 2 down beside it, I know that in this particular combination I've got 2 of them. Now the CO3 carbonate is my group. If I look up carbonate here, I see that it's CO3 with a -2 charge. And there is only 1 group there, and I know that because if there was more than 1 group, they would have written it as CO3 with brackets and then had some number here, however many there might be. Okay, so there's no brackets, there's 1 group, and it's balanced in this way. So how we name polyatomic ions, they're actually easier to name than the other ones, is just like before, we write the cation without changing anything. And then the second part is where we look up their polyatomic name. This is carbonate, and we write it as it is, no changes. Okay. All right, the second one, I see brackets here around NH4. NH4 is ammonium. It's the only positive cation on my group. Ammonium and CO3. So let's have a peek here. Ammonium is NH4 with a +1, and carbonate again is CO3 with a -2. Okay, so I've got 1, 2 groups of NH4, so I'll write them like this, with +1 charge, and I've got 1 group of the carbonate. And I write them just as their names are, ammonium carbonate. All right. Okay, well, I'm trying to keep the video short, so keep practicing and keep asking those questions.